product and quotient rules. If f and g are differentiable functions of x, then so is their product f times g. And in fact, the derivative of f times g is f prime g times g of x plus f of x times g prime of x. The quotient rule says that if f and g are differentiable functions of x, then so too is their quotient f divided by g. And in fact, that derivative is equal to f prime times g minus g prime times f divided by g squared, provided g of x is non-zero. We'll look at an example here. We want to find the derivative of x squared times 3x minus 1. We have a product here. We're multiplying x squared times 3x minus 1. So according to the product rule, we take the derivative of the first, which is 2x, leave the second term alone, 3x minus 1, plus leave the first term alone, the x squared, times the derivative of the second, which is 3. As another example, we could differentiate x cubed divided by x squared minus 1. Applying the quotient rule, we see that we need to take the derivative of the top, so 3x squared, leave the bottom term alone, x squared minus 1, minus the top term left alone, x cubed, times the derivative of the bottom, which is 2x, divided by the bottom term, x squared minus 1, quantity squared. Let's try a couple of examples. The first example, we're going to differentiate x to the 3.2 plus 1 times 1 minus x. We want to simplify the answer here. So we'll begin with the derivative of the first. That's 3.2 x to the 2.2. Leave the second alone, 1 minus x, plus leave the first term alone, x to the 3.2 plus 1. Take the derivative of the second, that's negative 1. We want to expand and simplify. And when we do so, we get 3.2 x to the 2.2 minus 3.2 x to the 3.2 minus x to the 3.2 minus 1. And collecting like terms, negative 4.2 x to the 3.2 plus 3.2 x to the 2.2 minus 1. Differentiating the second, we want to take the derivative. We want to look at this as x plus 1 being the first term, and then x squared plus 1 times x cubed plus 1 being the second term. So eventually we're going to take the derivative of the x plus 1, multiply it all by x squared plus 1 times x cubed plus 1, plus we'll leave the x plus 1 alone and multiply by the derivative of x squared plus 1 times x cubed plus 1. We do that, and the derivative of x plus 1 is 1. We leave the x squared plus 1 and x cubed plus 1 alone. Plus, we then leave the x plus 1 alone and take the derivative of the square bracketed term. Now that itself is another product rule. So the derivative of x squared plus 1 was 2x. We leave the x cubed plus 1 alone. Plus, x squared plus 1 is left alone times the derivative of the second, which is 3x squared. Put the x plus 1 into both terms in the square bracketed term and come up with our final answer. For C, we're going to begin by writing x times absolute x over 2 as a half x times absolute value x. We're then going to take the 1/2 outside of the derivative and just worry about the derivative of x times absolute value x. The derivative of x is 1. We'll leave the absolute value alone. Plus, leave the x alone times the derivative of absolute value x, which is absolute x over x. We're going to cancel a few things, collect like terms, and we end up with absolute value x.